Okay, so I also kind of sped things up by having the function already graphed there and the points, so I knew that they matched because the graph was actually graphed from those points, so I know I was right this time. I don't know, still don't know what the heck happened, but all right, so let's go on page 51. So I did a bad job of explaining the f of absolute value of x because the words came out of my mouth wrong, and then I think when I fixed it, people were still confused, but I want to add some stuff to this. So what I've done here, so here's your original function points, right? Which this is a domain that does not go out to infinity, so it doesn't keep on going at the endpoints. This is just a specific set of points here. And so that's a little bit different than when you're using your parent functions, okay? But here's what's happening here. We're going from -6 to 6 on our domain, right? So when we want the absolute value of the f of x, what is that the absolute value of? The x or the y? The y. Okay, so when you plug in x, x is x, right? So these are all the same. Does it make sense to you? I'm still going to plug in -6, -5, -4, -2, 0, and so forth, right? And then, so when you have, when you take the absolute value of the y part, right? So we've got all this right here. All these are the same. So these points all stay the same. We're just changing this one, and we get a +2, right? And we're changing this one, and we get a +4. So I put another little chart out there. The rest of them are the same. You can rewrite them if you want, but that's basically what's changing. Okay? So then we are going to plot these points. So we go to -6, 2, and a -5, 0, -4, 2, -2, 0, 0, 2, 2, 4, 4, 0, and 6, 4. 2, 4, 6, 2. Okay, there we go. All right, so it looks like this. So we keep the points where y is greater than or equal to 0, right? That's what happened. If y was greater than or equal to 0, they stayed the same. Points where y is less than 0 or negative, those points just get reflected over what? Because that's this point here. That's this point and this point, which were these and these. Those got reflected over what? The x-axis, right? And that's really our key points. That's not the only points, right? Because it's a continuous domain. So when we connect the dots here, these portions of the graph, all this stays the same, right? It's this part here and this part here that gets reflected over the x-axis. So when we connect the dots, this is what we get. Because these are the parts that were reflected in the x-axis. Everybody okay with that? So if you think about what it means to take the absolute value of y, that means if y was already greater than 0, it stays the same. If it was less than 0, then it gets reflected over the x-axis. So these pieces just get folded like that. Everybody okay with that? That one wasn't so bad. It was really the next one that I totally messed up on the wording and everything. Okay. So here, when we take the absolute value of x, we keep the points where x is greater than or equal to 0. We throw away points where x is less than 0. Oh, not less than or equal to, less than 0. Okay? So here's the difference between these two. Here we actually throw some stuff away. Right? Here we reflected them. Here it's just like totally gone. And I want to look at it from a graph perspective and a table perspective, because you've got to look at it from both. And it's a little bit easier to understand maybe from the graphical perspective, although it's not super accurate wording on this when you look at the example we did the other day, because I thought I did it wrong when I went back and got some clarification, and I actually wasn't wrong. It's just kind of a weird question. So when this happens, right, we are throwing away these points right here. Basically because when you plug in the -6, you're still graphing that -6. So the throwing away part, I'm not so sure about that. But when you take the absolute value of -6, when you plug it in, what's the absolute value of -6? 6. So the 6, when you're actually evaluating 6, it's at -4. So that 2 changes to a -4. This goes up here, right? Now -5 isn't even on here. So when I take the absolute value, it's +5. But when you go over here and you look, do you actually have a point for +5? 1, 2, 3, 4, 5, sort of, right? But we can skip that one and it might be okay. So let's just skip that one totally, and let's go to -4. -4 becomes 0, right? -2 would become 4. Everybody understand where that's coming from? Oops. So here's what it means by this up here. What's happening is this, is that you have these same points that you already had. Let's just go ahead and plot those. So we throw away the points where x is, oh my God, I put greater than or equal to 0. Oh, no, that's right. Keep. I'm sorry. I thought I did it wrong again. Good Lord. I'm sorry. I'm already having a bad day. Keep points. I was reading the throwaway part. Oh, my God. So I'm keeping these points. It's greater than or equal to 0. So let's go ahead and plot those. I'm going to go to 0, 2, 2, 4, 4, 0, and 6, -4. Right? So we're here. So if you just look at it from a graph perspective, what we then do is it says reflect the part you keep over the y-axis because it has y-axis symmetry. Right? This one actually has y-axis symmetry. So what's happening is when x is 2, you're at 4. That means when x is -2, you're also at 4. And see that right here? -2, 4. So when x is 4, you're at 0. So when it's at -4, you're also at 0, which is what we have right there. And then when x is 6, you're at -4. So when it's at -6, it's also at -4. If you can understand it from a graphical perspective, I think you're going to be fine. Because from a little research that I've done, we're not going to use this a whole heck of a lot anyway. All right? And the reason that you can't just think of it as just the reflection is because it doesn't work purely like that, like we did on Friday. All right. If the table part confuses you, think of it from this perspective right here. You throw away everything to the left that x is negative. Whatever you have on the right, it's just a reflection in the y-axis, and it's the same thing. And then you can fix your points after that. Okay? Yes. You're throwing it away because you're taking the absolute value of x. Right, exactly, because it's already positive. And notice how it's just like it's totally different than this. This, you can see how it flips up, and that flips up because it's a reflection. And the other one, maybe, it's like turned and stuff. This is like a totally different thing besides that one over there. Okay? We okay with that? All right, and I want to go back and look at the other one in just a second. Let me pause this real quick. Now, I want you to look back at your notes from Friday. Because if you use these words that go along with this, let's see, what was it right here? And we look at this one. Oops. So this is the absolute value of x, right? It says to throw away everything on the left-hand side. And then you take the right-hand side and you reflect it, right? But notice how this part isn't there. You see that? And so that was another thing that was throwing me off on Friday because I kept looking at what I had and I thought, no, that isn't right. And so I went and double-checked, and yes, the rule is to do that. So I had to go to a couple people because I kept getting answers that I didn't feel like were right. So when I talked to Mr. Ackerman, because I always go to him, and because I kept being told this part is supposed to be here, but that didn't make any sense to me, because if this is what we have, right, -6 isn't even a choice, right, because the x is what I get to control. Yes, the x has changed sometimes, but that's not what's happening here. So the fact of the matter is, on this one, when you do that reflection, this part isn't here. That's one reason why you kind of have to understand it from a table also. If this had arrows on the end to begin with, like we were going to keep on going to infinity, then I could see that we're reflecting the whole thing, but that's not what's happening here. All right, so I just wanted to make sure that you understood that this looks a little bit different, but it's not wrong. But in the grand scheme of things, the reason that we're even doing these obscure, weird little shape things is because we just need to understand it from some basic points so we can look at parent functions, okay? So most everything that you do with it, which won't even be that much, it will be an exact reflection, but this one is not, okay? Does that make sense? A little bit? Okay, you won't have to do that many of them. It's okay, and we'll get through it together, all right? Because I did